This is the grade 11 lesson 3.3, Exploring Exponential Relationships. Okay, so make sure that you have the paper that looks like this, Exploring Exponential Relationships. If you don't have it, go up and get one from me. Okay, so this is an interactive activity that we do with the class, so you're going to do it on your own. So I need you to get the following. I need you to get a scrap piece of paper that you were going to throw out anyways. So please pause the video, go get yourself a scrap piece of paper. Okay, now that you've got your scrap piece of paper, it should be a regular size rectangle. We're going to do something called a folding activity. And from this folding activity, we're going to see an exponential relationship. So I'm going to explain what that is in a second. So now that you have your paper in front of you, you should have 0 folds in the paper. So this column is going to be where we're going to record our folds, and this column is where we're going to record the number of rectangles that we have. So if you have no folds in your paper, take a look at it and see how many rectangles are on your paper. If you read it right, there should just be one rectangle. Now what I want you to do is fold the rectangle completely in half. So you're doing one fold, and ask yourself, how many rectangles are there in the paper? You should have 2 rectangles. I want you to fold it again and again and again. So you're going to fold it 2 times, 3 times, 4 times, 5 times, and then 6 times if you're really strong. I think the world record for folding a piece of paper is, I think, between 7 and 8 folds. So if you can beat that, you're quite strong. So I want you to fold it this number of times, and you're going to fill in the rest of this table. So please pause the video and go ahead and fill in the rest of the table. If you're starting the video again, you should be done folding the paper all of these times. And if you finish that, this is what your answer should be. You probably figured out the pattern somewhere around here. Once you realized that there were 8 rectangles after 3 folds, you probably figured out the pattern. So what is the pattern? Let's write it out here. Did you figure it out? How do we get from this number here all the way down to this number? Or how do we get from 1 to 2 and then 2 to 4 and then 4 to 8 and then 8 to 16? What are we doing? If you said that we are doubling or multiplying by 2, you are totally right. So on the right hand side here, it says, what is the relationship between the numbers? We're talking about the y. We can say we are multiplying by 2 every time. Okay, so this time we observed this pattern, but sometimes the patterns are difficult to observe, so we need a way to prove that the pattern is actually multiplying by 2 every time. So if you remember in grade 10 when we were dealing with these lovely things called parabolas, in order to prove that something was a parabola, what we had to do is we had to take looking at the y's, we had to take the bottom number and subtract the top number. Bottom number, subtract the top number. And if we did that 2 times and the differences equaled each other, we could say it was a parabola. If you didn't learn that, or if you don't remember that, don't worry. We are going to plot these x and y's on a plot. That's what we're going to do in our next activity. And when we do plot it, it's going to form a graph called an exponential relation, and it's going to end up looking something like this. So don't worry about copying this. But in order to prove that our pattern is multiplying by 2, and that in fact is an exponential relationship, just like parabolas, we have to work from the bottom to the top. I want you to just remember Drake and think about where he started. He started from the bottom, now he's here. So every time we do this, think about Drake. But we're not going to subtract like we did for linear relations or parabolas. We're going to divide. So the first thing we're going to check is we're going to check what 64 divided by 32 is. And we know that that is just 2. We're going to do it to the next one. Then we're going to do 32 divided by 16. We're starting from the bottom and going up. And that's also 2. Again, start from the bottom, now we're here. 16 divided by 8, also 2. You notice? All of these numbers are 2. Let's keep on going. Next we're going to do 8 divided by 4, also 2. And then 4 divided by 2, 2. And then 2 divided by 1, 2. So if these numbers are all the same, we have in fact found a pattern, and that pattern is that we're multiplying by 2 to the y's every single time. So now what I want you to do is we're going to graph this. So the first thing that I want you to do is make yourself a little y-axis and make yourself an x-axis. So we can label them, this one's x and this one's y. The y doesn't have to be perfectly in the middle. Okay, so instead of graphing this by hand, what I want you to do is I want you to pause the video, go back to Edmodo, and I want you to click on the following link. It will say Desmos paper folding number 1. There's 2. I want you to click on number 1. Then what you're going to do is when you open up Desmos is just a graphing calculator, you're going to see a table of values. You're going to see some x's, you're going to see some y's. So I've already inputted x equals 1, 2, 3, 4, 5, 6, 7, just like this. And what you are going to do is you are going to input the y's. So when x was 0, y was 1. When x was 1, y was 2, etc. Once you've inputted those, what it's going to give you, it's going to give you a whole bunch of dots. Look something like this. So go ahead and input those values in the Desmos paper folding link. Oops. There we go. Input the values. Then what I want you to do is plot them on our graph, just approximately. They don't have to be perfect, okay? So go pause the video, go to Edmodo now. If you are starting this video, you have gone to the Desmos paper folding link. You have inputted your values into the table of values I've set up for you, and you have transferred those points onto our graph. So if you plotted them correctly, you should have a plot that looks something like this. Okay, so you should have about 6 dots because we've got six values in x, and they'll look something like this. So this is the beginning of a graph. Can you see what shape this is going to make? If we connect these, is it going to make a straight line? Definitely not. If we connect these, is it going to make a parabola? Kind of looks like it. Maybe it could go up this way, but it's not a parabola. It's something called an exponential relation. And if we were to connect these dots, this is what it would look like. Oops. Okay. What's important about this graph is that, first of all, both the arms aren't going up. We notice that. One arm is increasing very, very quickly, or it could also be decreasing. In our case, it's increasing. And what the other arm is doing is getting closer and closer and closer and closer to the x-axis, but it's never, ever, ever going to touch. In the next lesson, we're going to look at this arm up close and personal, and we're going to zoom in, zoom in, zoom in, zoom in, and it's going to get incredibly close, but it's never, ever, ever going to touch. So again, what an exponential relation is going to look like is one arm is going to increase very quickly or decrease, and the other arm is going to get very, very, very close to the x-axis, but it's never ever going to touch. So now let's put everything together into our conclusions down here. So just so you know, you should have this graph. You should have this graph copied into your notes. So your notes should look exactly like mine, except for you don't need this Desmos paper folding. Okay, so let's put everything together in our little summary here at the bottom. So this graph that we have right here is called, not quadratic, not linear, but this is called exponential. So I'm going to write exponential. We can prove that it's exponential in 2 ways. We can prove it by looking at the graph, and we can also prove it by looking at a table of values. So when we have a table of values, we can prove that it's exponential by dividing the y values by the previous one. Remember, we started from the bottom, now we're here. We took the bottom number divided by the top number, the bottom number divided by the top number. All the divided answers will be the same. If they're not the same, it's not exponential. But if they are, we can prove it's exponential. We can also prove something's exponential by just looking at the graph, or we can describe what an exponential relation looks like. As you remember, one arm in the graph is almost touching. Almost touching. and getting closer and closer and closer to what? It's getting closer and closer to the x-axis. But it will never touch it. Never, ever, ever. This is called, you might have learned these before, these are called an asymptote. So what it is, it's like the x-axis is an invisible boundary that's keeping this relation from going past it. Okay, so what the other arm is going to be doing, while this arm is getting closer and closer and closer to the x-axis, the other arm is either increasing or it's going to decrease very, very quickly. So we're going to say it's increasing or decreasing very quickly. All right, so there's our conclusions. Let's go on to the final page where you're going to test yourself. The next page says, prove whether each relation is exponential or not. So we can prove it's exponential by looking at the graph. Do you see a graph? I definitely don't see a graph. But I see a table of values. How do we prove whether this is exponential or whether these points form an exponential relation by just looking at the table of values? Well, I want you to think of Drake. Start from the bottom and go up. So we're going to divide 243 by 81, and that just equals 3. And then we're going to do the next one. We're going to do 81 divided by 27 also equals 3. I'm starting to see a pattern. Let's see if it continues. Then we're going to do 27 divided by 9 equals 3. And then 9 divided by 3 also equals 3. And then finally, 3 divided by 1 equals 3. All these numbers are the same, so we have a pattern. If when we divide the bottom number to the top number over and over and over again, we get the same number, we can prove that this is exponential. This is exponential. I want you to do the same to the following. C, B, D. You're going to try them on your own, and then come back and check your answers. So if you're coming back to check your answers, you should have concluded that B is not exponential, C is exponential, and D is exponential. If you got a different answer than this, please come find me. First of all, check your calculations, then come find me and I'll help you out.